I'm going to start with some of these that were in the back of the book. Thank you. If you're converting 31.85 inches of mercury, you would write it like this: 31.85 inches of Hg over 1. And then over here, I should have done that differently. 31.85 inches of mercury. And over here, the first thing I want to convert is inches of mercury to millimeters of mercury. So I'm going to put inches of mercury down here, and this is going to be my conversion factor. And I get those numbers from over here. There's a table that I'll give you on the test. But millimeters of mercury is 760. Inches of mercury is 29.29. That should convert me to inches of mercury, or millimeters of mercury. So if I want to convert inches of mercury to millimeters of mercury, that's going to be the conversion factor. And same for the rest of these: 31.85 inches of mercury, inches of mercury. Inches of mercury is 29.29. Atmospheres is 1.00. So that'll convert to atmospheres, 31.85 inches of mercury. Converted to torr. Torr is the same thing as millimeters of mercury. So I'm going to put 760 torr. And 29.29 inches of mercury. Don't worry about kilopascals. So if I calculate these out, 31.85 times 760 divided by 29.29, 29.92. And then to convert to atmospheres, it's 31.85 divided by 29.92. This is 92. 31.85 times 760 divided by 29.92. 31.85 divided by 29.92. Torr and millimeters of mercury are the same, so this is going to be 809. Just to continue that a little bit more, I want to convert 652.5 millimeters of mercury to torr. Millimeters of mercury on top. Millimeters of mercury is 760. Torr is also 760. Those are just the same, so it'll be 652.5 millimeters of mercury, 1 atmosphere over 760. 652.5 divided by 760. 652.5 divided by 760. Atmospheres. If I want to convert to inches of mercury, I have 652.5 millimeters of mercury. Millimeters of mercury. That's 760. And inches is 29.92. So that's 652.5 times 29.92 divided by 760. And one more as an example, 652.5 millimeters of mercury converted to pounds per square inch. I'll get the 760 from the chart, and then the pounds per square inch is 14.7. So you build your conversion factors from this chart. These are your conversion factors. And that one equals 652.5 times 14.7 divided by 760, 12.6 psi. So these are just simple conversions. You guys okay with those? You just build them straight off that chart, and I'll give you that chart.
You're giving us a
Yeah. The chart is I should have this uploaded. Don't be too long. This chart. That's where I got all that from. Over on the left side of the screen. Table 10.org. Right. So that's pressure conversions. Let's do some of these. PV was NRT. I didn't make a lot of these because there's so many variations on it. But I'll go through this. So this PV equals NRT. You always do these when something's changing. We identify the information from these 8 variables. So this first one, initial volume is 12.2 liters. 2 liters. So this is the first one in my quiz in there. And at pressure 1.22 atmosphere. Atmosphere, that's liters. And then it says if the sample is compressed to a volume of 10.1, so 10.1 liters is the new. It does say constant temperature, but if it didn't mention temperature at all, you would assume that it's not changing. It doesn't mention moles at all, so you can assume that's not changing. And then the question is, what's the new pressure? This is where you start with, and you get everything that's changing on the left side and everything that's not changing on the right side. Just the natural way we write this equation, it's already there. I don't have to do any algebra. I've got P and V on the left side and NRT on the right side. So that's where you go P1, V1 equals P2, V2. You just repeat that. So that's the equation I'm going to use. I have 3 out of 4 variables here. It's P2 I'm solving for, so if I just divide both sides by V2, I'll have P1, V1 over V2, P2, and now I can just plug things in. P1 is 1.22, V1 is 12.2, V2 is 10.1, 1.22 times 12.2 divided by 10.1. And that'll be in atmospheres. So that should be the answer to that one. All right, the next one, question 2. Double checking my answer key as I go. So you want to set it up again. N1, T1. For the next one, we've got 44.5 milliliters for initial, and a gas cylinder, it goes from 26.6 to 88.2. Moles are not mentioned, and pressure is not mentioned. So it's going to be the volume and temperature on the left and everything else on the right. If I divide both sides by P and divide both sides by T, I get V over T and R over P. So 2 steps of algebra you can get there. The algebra lose anybody? You just manipulate that equation so you have B and T on the left, B and T on the left, and NR over P on the right. Don't forget, you have to convert these to Kelvin. So T1 is really 5, 7, 6, 7, 8, 5, 7, 8, 9. So I'm keeping those. So it's really 299.8 Kelvin.
Are you going to give us a conversion from?
I don't mind giving you 273.15. I'll give you that on the
You
test.
just add that to it?
Yeah, you just add it to it. That's 5, that's 3. 361, so G2 is 361.4. Okay. I didn't keep these when I made my answer key, so it's off by 1. Let's see. So now I've got my temperature and volume, so I'm going to go V1 over T1, V2 over T2. I'm just repeating that. I'm solving for V2, so if I multiply both sides by T2, I will get V1, T2 over T1, V2. And that's what I use to solve it. V1 is 44.5. T2 is 361.4. And T1 is 299.8. That equals 44.5 times 361.4 divided by 299.8. 3.6. And it will be in milliliters. I think I have 3.5 or something. I wasn't careful when I made the answer. I should say 55.6. That's the answer. And one more of these. There are more variations of this. It just depends on what 2 things are involved and what aren't. next one says, how was your break? Good break. I was sick all over break, so I didn't even get with family, so I didn't get people sick. I'm still sick, so I just had to say that so y'all would feel sorry for me. Okay, a balloon has 1.01 moles. It occupies 33.6 liters. One 1.22 mole is added. So I'm not going to put 1.22 here. I'm going to have to add it to this. So 1.22 plus 1.01, 2.23. See what I'm saying? That's what's added. That's not the new result. That's what I've got. Pressure's not mentioned. Temperature's not mentioned. So you're going to go EV equals nRT. You need moles and volume on the left side and everything else on the right. With a little algebra you can get here, RT over T. And then it's this. And you have 3 out of 4 of those variables, and we're solving for V2. Multiply both sides by N2. That should do it. V1 is 33.6. N2 is 2.23. N1 is 1.01. And it'll be in liters. 33.6 times 2.23 divided by 1.01. 74.2 liters. I only put 3 of those. If you wanted more examples of those, these 420 liters. So 33 through 40. So because there's lots more variations. Change what some things are changing, some things are not. You identify what's changing, you get it on the left side of the equation, and then you duplicate it and you solve. Ones and twos. PV equals RT. Okay, stoichiometry with gases. There's a couple of variations of this one. We looked at these earlier. I had to fix some things. I think I have it all fixed now. So the first one is stoichiometry. This is a 2-step process. You're given an equation for this first one. The reaction is 4Al solid plus 3O2 gas. 8L2O3 2 here. That's a solid. So working with this gas, the question is, O2 gas So what volume of this is needed to make 34.6 grams of this? So we're going to start with the grams. I need the grams per mole for Al2O3, which is Al2O3.
I have an app that does this automatically, but y'all know how to calculate that. Al2O3. Oops. Al2O3. 101.961
Grams per mole. And this is the way you use it when you want an equation. So you find out the grams per mole, we're going to have grams of Al2 on the bottom, Al2O3 on the bottom. And those grams are 101.961. Now I've got moles of Al2O3. 2, 3 on the bottom. This is going to be the mole ratio. It's 2 of those. To oxygen, it's 3 oxygen, so 3 moles of O2. And that's going to give you moles of O2. That is it's going to give you that energy for that equation.
Oh, the problem also gave you some other information. The problem also gives you that it's
Pressure, it tells you the pressure is 1.24 atmospheres, and the temperature. So you need that. I will give you this on the test, the R value, 8206. That's liters, atmosphere, mole, Kelvin, units. All right, so let's find out how many moles it is. 34.6 times 3 divided by 101.961 divided by 2 is 0.509 moles of O2. And now I'm going to plug that in here. But we're solving for, what are we solving for? Volume. So divide both sides by P, you get V equals N R T O P. Now I can just plug all these in because I have them all. N is 509, or 0.509. R is 0.08206. Temperature is 375. And pressure is 1.24. And that will tell us the volume of O2 needed to create 34.6 grams of Al2O3. 0.509 times 0.08206 times 375 divided by 1.24. Follow that. Do let me do this one, question 3. Very similar. It's done exactly the same way. But this time, the equation is 6 Li solid plus N2 gas. 2 N2 Li3N solid. All right. What volume of N2 is needed to make 11.6 grams of Li3N solid? And this time, 2.45 is the pressure at 396 K. Should I preserve all this? I'll just erase it. I'll get confused trying to do that. So same as we did before, we're starting with the grams. 11.6 grams of Li3N. We need the grams per mole for Li3N. Grams of Li3N. Use my app again. Li3N is 34,830. 34.830 grams per mole. So I've got that. Grams of Li3N cancel. I need moles of Li3N. This is going to be the mole ratio. 2 to N2, which is a 1. And that'll give us moles of N2. Which we'll be able to plug in to do it. All right. 11.6 divided by 34.830 divided by 2, 1.67, 0.167, 11.6 divided by 34.